So today we'll start the new topic at the center of mass. Okay, center of mass. So initially we calculate the center of mass for the discrete particle system. So what is discrete particle system mean? That means there may be different types of particles, and all those particles, let us say M1, M2, these are the two particles, and they are placed at different location x1, x2. Now what should be the center of mass of this system? So what is center of mass? Center of mass is nothing but the representation of a single point where if the particle of multiple particles are there, let us say M1, I want to replace that different particle by a single particle. So for that I should identify the location where I should replace. Okay. Just unmute yourself. Mute yourself. So if M1, M2, M3, M4, these are the, let us say, different particles are there. Okay. So let us say this is the M1 particle, this is the M2 particle, M3 particle, number of particles are there. Now your objective is to replace the all particle by a single particle. That means at this point I want to replace the entire mass. Let us say M1 is 2 kg, M2 is let us say 4 kg. I want to replace 2 kg and 4 kg by a single mass 6 kg, but I want to replace it by one single mass. Okay, instead of two mass, I want to replace it by a single mass of 6 kg, but what should be the proper location so that the system will be equivalent. Okay, so center of mass is nothing but the equivalent point to where the resultant weight is acting or resultant mass is acting. So what is the logic behind it? Let us say there is a football and I am resting this football in our hand. That means with my fingertip I am applying a force in this direction, normal force, and the entire body is under equilibrium condition. That means that must be the situation where the normal is passing through the center of mass of this situation. Okay. So if the entire normal force is passing to the center of mass, generally the force is balanced. If say, let us say this is the center of mass, through the weight is being acting, and I am applying the normal over here, that means now these two are not passing to the same line. So now the body will not be in the equilibrium situation, it will fall down. Okay. So in order to balance a particular body, I have to apply the concept of center. Center of mass is nothing but the point where the resultant mass is acting. So this is the distributed mass. This is the, let us say, the mass of the body is, let us say, 2 kg. So entire 2 kg mass is distributed through the sphere, a spherical body. Now the entire body is replaced by a single point where the entire mass is being concentrated. So this is the point where the entire mass is being concentrated. That point may be the geometric center, may not be the geometric center, depending on the distribution of mass. Okay, there are different parameters based on which I have to evaluate the position where the center of mass is there. But the idea is that you want to replace the entire mass by a single mass, and essentially that mass that has to be placed at the center of mass, it should be the point. It should be the point mass. Initially the mass has some kind of dimension. Let us say this R is the dimension of the ball. Okay. But once I replace the entire mass by a single point mass, that is now at this point I am replacing one single body whose mass is the point mass, that is, it should not have any kind of dimension. Okay. So why the idea is important? The idea is important because there may be the particle. Let us say I throw a boomerang. Let us say I throw a boomerang body. So like this way, once I throw this, the particle is following a particular path. Particle is following a particular path, and that path is well known to us. Why? Because this path is nothing but the projectile. Though each and every point of the body is performing not the projectile path. But the idea is that, let us say this is the shape of the body. Let us say this is the shape of the body. Okay. And if I say this is center of mass of the particle, always center of mass will particle of the center of mass of the path is the well known path. The path in which the center of mass is a well known path, that is the projectile path. But all the other point that is not on the center of mass, let us say I say this is the one point A. So the A point may rotate in this direction, may translate in this direction. So there is a complicated path of the point B. But on the reference frame of center of mass, if I observe the entire movement of the particle, then that movement is quite easier to understand. Why? Because this is center projectile motion. Okay. So center of mass gives the idea that if the particle, let us say, in this situation, I throw a pencil. Now, whose center of mass is like this? So every time if I track the center of mass is performing a purely projectile path. Purely projectile path, which is we already understand how to calculate this projectile path movement. But if I locate any other point on this path, let us say I want to study this point. Let us say this is the point A. After some point of time, A is over here. After some point of time, A is over there, like this way. These are the defined location of point A. So the point A is performing a defined path, but the center of mass is performing the projectile path. So what is the movement of the projectile? What is the movement of the point A? So point A has two different velocity. One is the rotational speed. So point A is rotating about the center of mass. Let us say with omega. So point A is performing a circular motion about the center of mass as well as a translatory motion. Point A has two different velocity. One is the translatory velocity and the rotation component. So because the rotation component it is rotating, because the translation is performing a circular motion. So both the movement has to be identified. So that means it is quite difficult to study the movement of any other point other than the center of mass. Okay. So the special point where the entire mass of the system is supposed to be considered is called the center of mass. Okay. So if we throw a pen, it performs rotational motion, but a special point performs translating motion. Okay. So all the points are performing the rotation as well as translation, but only the center of mass is performing the pure translation. So there is no rotation of the center of mass. So that's why it is quite easier to understand the movement of this particle. That's why I decide to go for the center of mass equation. So let us see this. So in this equation, the racket is being thrown. Okay. Now trajectory of this particular body, I want to establish what is the trajectory. So this is the computed path in which the entire racket is moving. Okay. I could not understand what is the exact path in which the racket is moving. Now repeat the same process on the handle. Let us say if I go for the handle part, so handle is moving upward, then downward, then again upward, again it is computed path. Okay, so this is the trajectory of the handle part. Okay, now go for the movement of the center of mass. So once I focus on the center of mass, the center of mass is performing a pure trajectory, a parabola. Okay, depending on the defined points are performing defined movement, but center of mass is always performing the trajectory which is the parabolic path. Okay, now based on the center of mass, so if I observe the defined points on the center of mass plane, then these are performing pure circular motion. Okay, so idea behind this is that if I throw a body, let us say this is a body, I throw about the center of mass, so center of mass is moving with omega, let us say omega. So all the points, A point, B point, C point, if I see the point A or point B with respect to the center of mass, so with respect to center of mass, they are performing the pure circular motion, and individually the center of mass is performing a projectile motion. Okay. Now these two motions are quite understandable to us because we have deeply studied these two motions. Yeah. So that's why the end point or the midpoint or any other point performing different types of motion, but center of mass is performing always a particular type of motion which is known to us. So there are two types of system. One is called the discrete system and called the continuous system. Discrete means the different particles are placed at different location. On an xy plane, let us say there are three particles. One is a 3 kg, another is 3 kg, another is 4 kg. The coordinate of 3 kg is given, coordinate of this 3 kg is given, coordinate of 4 kg is given. Okay. So total mass is how much? 3 plus 3, 6 plus 4 means 10 kg. So you want to replace the entire 10 kg by a single mass 10 kg. So initially you have three different masses. Now you want to replace the three different mass by a single point mass of 10 kg. Now the position of this 10 kg is nothing but the position of center of mass. So it has two different coordinates. One is the x coordinate of center of mass, and the y coordinate of center of mass. So under the discrete particle system, I want to focus at what location the entire mass has to be placed, so that it is basically replicating replacing the initial system. So initially there are 3 particle system. Now I replace the 3 particle system by a single particle system. Now what is the position of that single particle system, that I want to understand. Similarly the situation for the discrete. Similarly the situation for the continuous mass system. So whenever the continuous mass system, that means it is nothing but a made of different dm mass. All this dm, these are the discrete particles. So infinite discrete particle system gives us the continuous system. And so how many dms are there? Infinite. So can I say the infinite number of dm particles, when they are arranged, they are basically giving a discrete particle system. Here they are giving a continuous particle system. So under this continuous particle system, again I want to check what is the point where the entire mass is concentrated. What is the point where the entire mass is being concentrated? That means I want to locate that coordinate. Okay. So for a discrete particle system, let us say you have n number of particles. N number of particles are there. Now these particles M1, M2, M3 are placed at a particular position vector R1 vector, R2 vector, R3 vector, like this. What is R1? R1 is nothing but the position vector of area. So let us say the coordinate of M1 is x1, y1, z1. So similarly, what I can write that R1 vector is nothing but x1i plus y1j plus z1k. Okay. So similarly, R2 vector, R3 vector. So all are the different position vector of different particles of M1, M2, M3. So now the concept is that if I say there are different particles and these particles are the pointers, so that means these particles should not have any kind of dimension. So what is the net product of mass into arc distance? So that is called the moment, area mass moment. Okay. So what we calculate that, consider a coordinate system x, y, z. Consider M1, M2 the point masses. These masses are positioned between R1, R2, R3. The center of mass of the entire system having a position vector of RC. So my question is to calculate what is the center of mass of this system. Where there are, let us say, 3 particle or 4 particle system is there. So for that I calculate first we calculate the total mass moment. What is that mass moment? So mass moment is nothing but the moment, or what you say, product of m into r vector. Okay, product of m into r vector. So first vector is m1. The first mass is m1. So m1 into r1 vector plus m2 into r2 vector plus m3 into r3 vector. Like this way, I calculate the total mass moment. Okay, this is called the total mass moment. Now that has to be replaced. So once I replace the entire system by a single mass, center of mass m, what is that mass? Total mass. So that total mass is nothing but m1 plus m2 plus m3 plus up to mn. Why? Because by the idea of center of mass, I am going to replace the discrete particle system of n number of particles by a single mass. So now what is the mass moment for this mass? So if the center of mass is placed at a distance of r, so this is the RC vector. Okay, so mass moment for the mass that is placed in the center of mass, that should be equals to how much? Then m1 plus m2 plus up to mn into r vector, RC vector. Okay. So this moment and that moment must be equal. So if I equate these two, what is that? So initially we calculate the moment or the mass moment for individual particle. Similarly, once we calculate that number, now we calculate the total mass moment of the mass placed at the center of mass. That is this number. So if I equate these two numbers, so correspondingly what we call RC vector should be equals to how much? M1 R1 vector plus M2 R2 vector plus M3 R3 vector divided by M1 vector plus M2 plus M3 like this. So this is basically give the coordinate or the position of the center of mass. Position of the center of mass. So that is the idea of the center of mass, that is called the RC. Okay, so that gives the entire position or the coordinate of the center of mass of the discrete particle system. So you have n number of discrete particles. So you replace the n number of discrete particle by a single particle placed at the coordinate RCA. So now if I elaborate this RCA number, then I can say that RCOM, if I say this is the RC number, RC is for two particle system. Let us say I want to apply this formula for the two particle system. So it should be equal as M1 R1 vector plus M2 R2 vector here by M1 plus M2. Now, what is R1? R1 is the position of the M1. That means, can I write? It is equals to M1 into X1I plus Y1J. Okay. Plus M2 into X2I plus Y2J. Whole here by M1 plus M2. Now, if I take the I component together and J component together, so further I can write that M1 X1 plus M2 X2 divided by M1 plus M2. That is the I part. Similarly, that is equals to M1 Y1 plus M2 Y2 divided by M1 plus M2. That is a J. That means there is a quite similarity between the R number. So once we calculate the R number, so R is the position vector of the center of mass. So for a 2D system, it has some kind of X component and some kind of Y component. So this gives the X component of the center of mass. This is called the X. And this is the Y component of the center of mass, YC. So if the particles is more than 2, then we can expand this number by M1 X1 plus M2 X2 plus M3 X3 like this way. And in the denominator, M1 plus M2 plus M3 like that way. Okay. So this is the, in general, for any n number of particle system, the calculation to find what is the X location and what is the Y location of the system. But for a two particle system, so can I write XCOM is this number? Yes, I can write because this is the formula. Okay. Now, if I join the two particle system by a straight line, then corresponding to this, if I place my origin at point M1, so here I am placing my origin. If I place the origin over here, then for this M1 particle, can I write X1 is 0, Y1 is 0? Because this is the X coordinate, Y coordinate, the M1 particle. Similarly, if I say M2 is located at a distance of R from the origin, so coordinate of M2 is basically R comma 0. Okay, so R comma 0 is the coordinate of M2 and 0 comma 0 is the coordinate of M1. Why? Because I am placing the origin on the M1s. So if I apply this concept, so corresponding to the what we can write, we can further simplify that M1 into X1. What is X1? 0. M1 into 0 plus M2 into R. Here M1 plus M2. Okay. So that means what I am getting, that X center of mass is equal to M2R. Here M1 plus M2. What is the X number? X number is the position of the center of mass measured from the M1 itself. So this distance is called the X2 number. Similarly, if I want to calculate the position of the center of mass measured from the M1, so this number should be equal to how much? This number should be R minus X2. That means R minus M2R divided by M1 plus M2. Or if I simply M1R divided by M1 plus M2. Okay. So these are the two sub-formula, you can say, which can be applied for only two particle system. Important concept is this one. So I can calculate the coordinate of X, Y and Z separately by applying the formula. Or instead of applying the three different formula, X, Y, Z calculation, I can apply the two point mass formula. 2 point mass formula means this formula. So whenever there are two particle system, whenever there is a two particle system, then let us say, I am saying there are two particle system. Let us say this is a 2 kg, this is a 4 kg. Okay, two particle system. The gap between this 2 kg and 4 kg, let us say 6 meter. Okay, so I want to calculate the location of center of mass. So if I say this is the location of center of mass should always be shifted towards the higher mass. So it should be towards the 4 kg. So this is the center of mass. So if I want to calculate this distance, that means now I want to calculate the distance of the center of mass measured from the 2 kg. If I say this is R1 number, so formula for R1 should be equal to, since R1 is measured from 2 kg, in the numerator put 4 kg. In the numerator put the 4 kg and the denominator put total mass 36 kg. Okay, so take the ratio 4 by 6, multiply by the distance between them by 6 meter. So answer is 4 meter. Okay, What is the tricks? Tricks is that whenever you want to calculate the R1 number, R1 is the distance of the central mass measured from, let us say, 2 kg. So in the numerator, other mass to be taken in the numerator. Total mass is the denominator multiplied by the distance. So similarly, once we calculate the R1 number, so once calculate R2, R2 is the distance measured from the 4 kg. So take the mass 2 kg in the numerator, divided by 6, and divided by 6, equals 2 meter. Obviously, if the R1 is 4 meter, then R2 should be 2 meter. Why? Because the distance between them is 6 meter. Okay. So this is the concept of two particle system. And in general, I can apply the two particle system multiple times to get the n number of particle system. Okay. So that makes the problem to be approached in two different ways. Either I can calculate the entire system as a single setup, or I have to apply multiple system. Same logic, if I say there are two particles, they are moving with some different velocity, v1, v2. I want to calculate the velocity of central mass. So for two particle system, or more than two particle system, it is also applicable. If I say RC is the position vector of the central mass, that is equals to m1 r1 plus m2 r2 divided by m1 plus m2. That is the most general formula. So if I differentiate it both sides, so what I am getting, that drc dt. What is drc dt? drc dt is the rate of change of position of the rc with respect to time. That means nothing but the velocity of central mass. That should be equal to m1 into dr1 dt, because mass is constant, plus m2 into dr2 dt, like this way, and denominator is m1 plus m2 plus m3. So ultimately what I am getting, that is V center of mass should be equals to m1 into velocity of 1 plus m2 into velocity of 2 plus dot 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 divided by m1 plus m2. But these velocities are to be in vector format. Okay. So that will be the velocity of central mass. That will be the velocity of central mass. So similarly, once we calculate the radius of the position of central mass, that will now I differentiate it to get the velocity. So velocity of individual particle v1, v2, v3, v4, they are different. Once we take the total effect, I am getting the effect for the center of mass. So what is the velocity with which the center of mass is moving? Same logic goes for the acceleration also. Same logic goes for the acceleration also. Similarly, the acceleration of center of mass, if I say the acceleration of center of mass, a1 is the acceleration of 3 kg, let us say a2 is the acceleration of 2 kg. So a center of mass can also written as equals to m1 into a1 vector plus m2 into a2 vector plus dot 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 divided by m1 plus m2 plus m2. Okay. So the same formula can be applied to find the position, to find the velocity, or to find the acceleration. Okay. So we calculate the velocity, we calculate the acceleration. So all are same type of formula. Okay. So what is the gist? Gist is that in order to apply this formula, one important consideration is that the particles will be point. If the particles are point mass system, then only you can apply this formula. And with this formula, you have to apply in such a way so that you have to take care about this vector. Okay. These are the vector quantity. You have to take the proper sign. Then only you can say what is that. So let us say there is two masses, 2 kg and 4 kg. 4 kg mass is shifted by 4 meter towards right. You shift this 4 kg mass by 4 meter towards right. Okay, 4 meter. Then by what distance 2 kg should be shifted so that the central mass should be shifted by 1 meter towards right. Okay. So initially this is the central mass. This is central mass. Now you are asked to calculate what is the change in the central mass position, so that what is the change in the position of the 2 kg mass, so that the central mass should be shifted towards right. So initially, we are the 2-point mass system. So what we can write that x center of mass should be equal to m1 x1 plus m2 x2 divided by m1 plus m2. That is correct. Okay. Now since we displace this particle system, so if we differentiate it, we write dxc. So dxc what? Dxc is the displacement of the center. That should be equal to how much? m1 into dx1 plus m2 into dx2 divided by m1 plus m2. Okay. So use the proper sign. So center of mass should be shifted 1 meter towards right. So dx is 1. M1, let us say is the M1 particle, this is the M2 particle. So what is dx1 that we want to calculate? So 2 into dx1 plus M2 is 4 kg into dx2. dx2 is 4. Thereby M1 plus M2 is 6. And M1 plus M2 is 6. So ultimately I am getting 4 4 the 16 minus 6 means dx1 should be equal to minus 5 meter. Now, so 6 minus 16 is 10 by 2 means minus 5 meter. That means dx1 is minus 5. That means you have to move the M1 particle in this direction by a distance of 5 meter so that the center of mass should be shifted towards right by 1. Okay. Now, in the same question, if I ask to calculate what is the shifting of M1 so that there is no shift of center of mass. So that means for center of mass is at rest. That means in this situation, dxc number should be equals to 0. If dxc number should be equals to 0, that means what we can say that m1 into dx1 plus m2 into dx2 should be equal to 0. Now, that means what we can say 2 into dx1 plus 16 should be equal to 0. Now, that means dx1 should be equal to minus 8 meter. Why? Because that means in this situation, in the second situation, if I say that the entire center of mass should be at rest, it is not moving. For that situation, if I displace the 4 kg towards right by 4 meter, that means the 2 kg has to be displaced towards left by 8 meter. Then only the center of mass will be at rest. Understood? So this is the concept. Now we want to calculate the center of mass of a 3-particle system. All the particles are placed on the vertex of a triangle. Equilateral triangle. Let us say with the equilateral triangle. So first place the coordinate system, axis system over here. Now identify what is the coordinate of the particle system. The coordinate is basically for the first particle it is 0, 0. This is the origin. For the second particle it is equals to a, 0. And for the third particle, this is the median part. So that is a by 2 is the x coordinate and a sine 60 is the y coordinate, that means a root 3 by 2. Okay. This is the a by 2 is the base and a cos 60. So y is the angle 60 degree. So this is a sine 60 is the y component, a cos 60 is the x component. So you got the 3 different particles and their coordinates. So finally what you can write the x center of mass. So if I x center of mass means m into 0 plus m into a plus m into a by 2. Okay. So first coordinate is 0. First coordinate is 0 x1. Second coordinate is x2. Third coordinate is a by 2. So m1 x1 plus m2 x2, all those numbers divided by total mass. Total mass is 3m. Okay, total mass is 3m. So in the numerator, I am getting 3ma by 2, ema by 2 whole divided by 3m. That means a by 2. X center of mass is a by 2. Similarly, y center of mass. So m1 into 0, first number. Second number is m2 into 0. Third number is m2 into a root 3 by 2 divided by 3m. Okay, that means what I am getting? A root 3 by 2 divided by 3. That means a by 2 root 3. Okay, a by 2 root 3. So finally, once I got this number, so that means the center of mass will be located somewhere over here, where this coordinate is the x coordinate, that is a by 2, and this is the y coordinate. This number is how much? Is a by 2 root 3. Okay. So now at this position, so if I replace the entire 3 mass system, so I am placing one single mass. What is the mass placed over here? At this point, I am placing a mass of 3m. Okay, instead of putting 3 different mass at the 3 corner, what I am doing, I am putting one single mass at the center of mass position, so that the entire mass unit system will be equivalent. Entire system will be equivalent. So like this, so let us do this. Locate and position center mass of m1 m2 separated by distance d. So simply I can apply the concept of 2-particle system. So this is the center mass, let us see. So if I say this is the coordinate, This is the x coordinate. So let us say this is the R1 number. So what is that R1 number? R1 should be measured from M1. So in the numerator M2 will be there. Here by M1 plus M2 into total distance between them. Total distance is how much? D. So that is the x coordinate and y coordinate is 0. Okay. So x coordinate is M2 D divided by M1 plus M2 and y coordinate is 0. So option number A is the correct one. Similarly, this number. So this is already done. Okay. So here the locate the center of mass of all the coordinate system is given. So coordinate is given, but now the particles are of unequal masses. Now the particles are of unequal mass. Concept remains same. So if I calculate the x center of mass, so x center of mass should be, let us say, is the first particle, second particle, third particle. So for the first particle, its coordinate is 0. So am into 0. Second particle 2m into a. Third particle am into a by 2. Divided by total mass. Total mass is 2m plus m plus 2m. M plus 2m plus m. Okay. So ultimately 2ma plus ma by 2 means 5ma by 2. 5ma by 2 divided by 4m. 4m. So ultimately I am getting 5a by 8. So 5a by 8 is the x coordinate. So similarly y coordinate should be the option A. Okay. But again you check it whether you are getting the correct YC number or not. So for y coordinate, for the center mass, again first particle m, y is 0. Second particle 2m, y is 0. Third particle m, y is a root 3 by 2. Whole divided by m plus 2m plus m. Ultimately I am getting a root 3 by 2 divided by 2 or 4. That means a root 3 by 8. Root 3 by 8. Root 3 by 8 into. So that is the y coordinate. So option number A is the correct. Okay. So every time you have to identify how many particles are there, then you apply the formula that is m1x1 plus m2x2 for each and every coordinate system. Similarly, I can get the x coordinate, y coordinate, and z coordinate the particle in 3-dimensional system. Now look at the x coordinate center mass of the following particle. Now there are different particles and placed at different location. Starting from 0 to 99. So for each and every particle, the coordinates are given. So only since the particles are aligned along the x directions, only the x coordinate is there. No y coordinate. So x coordinate should be let us say the first particle, the second particle, third particle, fourth particle, like this. So first particle is a into 0. Second particle a into a. Third particle a into 2a. Fourth particle a into 3a. Like this way, last particle is a into 99a. Divided by total number of particles. How many particles are there? The number of particles is 100. So 100 m. In the derivative is 100 m. Okay, total number of particles are 100. So total 100 m. So if I add the first part, so first part is take m common. So then first number is a, take out 1 plus 2 plus 3 plus up to 99. So this is the sum of 99 numbers here by 100m. Okay. So sum of n natural numbers. Sum of n natural numbers is a by 100. So it is first number plus last number a plus l by 2 into n. How many numbers are there? How many numbers are there? That is total number of 100. Total numbers are 100. So it is less than 1 and 99. 99 n by 2 into a plus l. So n by 2 into a plus l. So 99 by 100 means this number cancels out. So 99 by 2 into a. So that is 49.5. 49.5. That is your answer. Okay. Got it? Yes, sir. Next. Now the particles are positioned along the vertex of a cube. Particles are positioned along the vertex of the cube. Now, if this problem you are trying to solve using the coordinate method, then it will be much more difficult. Why? Because there are 8 particle system is there. For each and every 8 particle, the coordinate is different, so you cannot write. So for that, what you should go for the 2 particle system. Okay. So let us say, if I say these are the 2 particles. So let us say 1 and 2. So these two are symmetrical particles. So if I replace these two particles, so can I say these two particles replaced by one single particle 2m over here at a distance of this distance how much? A by 2. Now, similarly, if I go for 3 and 4th particle, so again it is replaced by another 2m particle. Another 2m particle. So now this 2m are again replaced by another 4m particle, which is at a distance of a by 2m. So this is the 4m particle, which is a distance of this distance is again a by 2, because it is intersymmetrical system. Okay. Now this 4m is replacing what? This 1, 2, 3, 4 front side particle. Similarly, if I go for the same analysis, this, let us say 5th, 6th, 7th and 8th. So this 4m particle is replaced by another 4m mass over here. Okay. Now these two 4m. So one 4m is over here. This is one 4m and there is another 4m. What is the difference between these two 4m? The coordinate of this 4m is how much? X is a by 2. X is a by 2, y is a by 2, z is 0. Here the coordinate is a by 2, a by 2, 0. For this 4m, x is a by 2, y is a by 2, y is a by 2, z is also a. For this 4m is placed on the front plane. This 4m is placed in the front plane. So for this 4m particle or the point mass, x coordinate is a by 2, y coordinate is what? A by 2, z coordinate is a. Okay. Now again you replace this by a single particle, that is 8m over here. So this is the finally 8m mass is placed at the center mass. Now again it should be at the midpoint. At the midpoint means now the z coordinate becomes, so why z coordinate? This is the z direction. This z direction. So it should be again a by 2. It should be again a by 2. So finally this coordinate is how much? A by 2, a by 2, a by 2. Got it? That will be your answer. Okay. If you calculate this by this method, then only it will be easier. If you want to calculate the same problem using the concept of coordinate method, that means you first write all the coordinate of each particle, then you want to simplify it, it will make the complex, maximum complex. So depending on the situation, so there will be different types of situation. Okay. Now find the acceleration of the center mass when the system is released from the base. Acceleration. So acceleration of the center. So again there are two particle system. Now initially both these particles are moving in different speed. Both these particles are moving different speed. So first calculate what is the acceleration of individual part. Let us say for this pulley block system, can I say this block force is 20 Newton, here the force is 30 Newton. Okay, so acceleration of the system should be in this downward direction A. What is that A number? That should be 30 minus 20 divided by 5 kg. Understood? That is the acceleration system. So how much? 10 by 5, that is 2 meter per second. So 2 meter per second square is the acceleration of both 5 kg and 3 kg and 2 kg. Now we are asked to calculate the acceleration center. So for that, its formula is what? AC is equals to M1 into A1 plus M2 into A2. Here A1 plus M2, that is the formula that I am going to apply. Okay. So if I take this downward A is positive, so 3 kg is moving downward with an acceleration of A, that means 3A. 2 kg is moving upward with an acceleration same A. So if downward is positive, then upward is negative. So minus 2A divided by 3 plus 2 means 5. So answer is A by 5. Now what was A? A is 2. So 2 by 5 meter per second square. 2 by 5 meter per second square, that is the answer. So 2 by 5 meter per second square, that is the acceleration, that is the positive number that I am getting. That means the entire acceleration is down. So 2 by 5 meter per second square downward is the acceleration of the center. Individually, the 3 kg is moving downward, 2 kg is moving upward, the acceleration are same. But the center of mass is moving some different acceleration. Center of mass is moving with some different acceleration. Similarly, in this situation, so there are two identical particles are released from the fixed inclined plane, and if these angles are fixed, these numbers are fixed, that means this slope is smooth or the frictionless surface, smooth inclined plane is given. So I know that individually this part will moving with axis v sin theta, that is moving with v sin theta. Yeah, axis will be defined. Now you are asked to calculate the axis center of mass. Okay, so here the answer should be g sin 53, means it should be 4g by 5. Here the expression is g sin 37 means 3g by 5. Why? Because the surface is fixed. So individually, the block number 1 and block number 2 are having different acceleration. But you are asked to calculate the acceleration of center of mass. So for that, you have to write in vector form. Earlier question is either upward or downward, but here what I am getting, the vectors are not aligned. If I say these are x-axis, and these are y-axis, let us say these are y-axis. Okay, so 3g by 5 has two components. 3g by 5 cos 37 along x direction. 3g by 5 cos 37. So 3g by 5 into 4 by 5 means 12g by 25. Now, similarly, 3g by 5 sin 37. 3g by 5 into 3 by 5. 9g by 25. So these are the two components of acceleration of 3g by 5. Similarly, another two components of 4g by 5. So 4g by 5 has x component in this direction. So 4g by 5 cos 53 means multiplied by 3 by 5. So 12g by 25. So 12g by 25, and the downward direction it should be equals to how much? 4g by 5 into sin 53 means 4g by 5 into 4 by 5 means 16g by 25. 16g by 25. Okay. So these are the different acceleration of the mass 1 kg and 2 kg along x and y. So clearly it has been seen that acceleration of the interparticle, let us say if I want to calculate the acceleration of center of mass along x direction, it should be equals to m1 into x1, m1 into a1x plus m2 into a2x. Here m1 plus m2, that will be your answer. Now what is the m1 mass? m1 is m. What is the acceleration of m1? Along x direction is 12 by 5. So if I say this is 12 by 5 positive, that 12 by 5 will be negative. Okay. So m into 12g by 5, 12g by 25 minus m into 12g by 25 divided by total m. So that means the acceleration of the center of mass along x direction is 0. Acceleration center of mass in x direction is 0. So only acceleration remains in the y direction. So what is the acceleration along the y direction? Acceleration center of mass along y direction should be equals to, so this 16 by g's and 9g by 25, they will be added up. They will be added up. Why? Because both are in the same direction. One is 16 and another is 9. So 16g by 25 plus 9g by 25 means how much? G. So 16g by 25 plus 9g by 25 whole divided by 2. Why 2? Because mass is 2m. In the numerator with 1 m is there. So ultimately what I am getting? G by 2. 5 meter per second. And 5 meter per second square is coming downward. Why? Because I am taking y is positive downward. Y is positive downward. So your answer should be 0 and minus 5, because in this question y is taken upward to positive. Okay. So whenever you want to calculate the velocity and acceleration, take the concept of vector quantity and accordingly you have to apply the concept. Let us say there are three identical balls are projected in three different directions as shown. U1, U2, U3. You are asked to calculate the time of flight, maximum height and range of the center. So first you calculate the center of mass. First you calculate the velocity of center of mass. So three balls are identical means all are having the same mass. So in vector notation, the velocity u1, u2, u3 are given. So I can write the u for center of mass should be equals to m1 into u1 plus m2 into u2 plus m3 or m into u3. All are same. Divided by 3m. Ultimately what I am getting? u1 plus u2 plus u3 by 3. So what is that number? Minus 3 plus 6 means 3i. plus 4 plus 4 plus 4 means 12. 12j whole divided by 3. That means I am getting I plus 4j. Okay. So I plus 4j is the velocity of the center of mass. That means center of mass, if I replace the entire particle, if I concentrate on one particular particle, so for this particle, the velocity of the x direction is 1 and velocity of the y direction is 4. Okay. So time of flight is what? Time of flight is 2 times of uy by ag. So 2 into 4 by 10 means 8 by 10 means 0.8 second. Maximum height capital H should be equal to uy square by 2g. What is uy square? 16 by 2 into 10. That means 0.8 meter. And finally R. R is what? Ux into capital T. Ux is 1, capital T is 0.8. 0.8. Okay. So these are the answers. So once you replace the three defined balls with a single particle, then entire particle answer is different. Okay. Individually, U1, first particle, second particle, third particle, all are performing different types of motion. But as a whole, if I replace this system by a single point mass, the center of mass, it is again performing projectile type of. Yes. So this is the second part of the center of mass topic. Now we go for the calculation of center of mass for a continuous system. That means now the mass is being distributed. So mass is being distributed. So there are different topics under this. So this is the very basic calculation that you have already done. That is the position of x center of mass, position of y, position of z, position of, or calculation of the velocity, and calculation of x. So these are the 5 different points. Based on that, we formulate the calculation of the center of mass for the discrete particle system. Now we elaborate this for the distributed particle system. So distributed particle system means whenever this monkey is moving along this rope, so monkey is balancing himself by placing his arm right or left. Okay, that means in the process of doing that, every time he ensures that his center of mass is passing through this rope itself. Okay, so if I say this is the rope, so its center of mass is acting in this direction. So weight is acting through the center of mass. So by placing the right hand or the left hand, he is adjusting in such a way so that every time the center of mass is falling through this guard wall, that means he will not fall. Okay. So this is the idea. So that means the center of mass for the continuous body. So first task is to draw the idea for the regular shape body. If the body are regular shape, then it will be the cylinder. So for the cylinder, the center of mass will be on the geometric center. That means it is at the half of the height. If I say the h is the height, so h by 2. If the triangular lamina is there, then this is the center of mass is the intersection median. So if I say this is the height h, is the height h, so median is to be located at a distance of 2h by 3 from the base. Okay, h by 3 from the base. If it is a square or rectangle, then it is the intersection of the diagonal. That is the center of mass. That means if I say this is the a by 2 and this is the b by 2. Okay, what is b? B is the width and a is the length of this geometry. Okay, so these are the regular shape geometry. For regular shape geometry, geometric center is nothing but the center of. Okay, but whenever I go for the irregular shape geometry, that means it is not a regular one. So for that I have to apply the concept of integration. Okay, so instead of considering the different masses, I am saying dm, dm, dm. These are the different elemental mass. Okay, dm are the different elemental mass. So I want to calculate what number? So I want to calculate the moment of this dm. Mass moment of this dm, mass moment of dm2, mass moment of dm3, like this way. That means in the numerator, what I want to calculate, that is the product of dm into r, that number. Now, product of dm into r for the particle number 1 plus product of dm into r for the particle number 2. Like this way I want to calculate in the numerator. And the denominator I want to calculate the dm for the particle number 1 plus dm for the particle number 2. Like this way. That means this gives the idea that I want to calculate a repetitive sum. So numerator is nothing but a summation of DMR, summation of DMR like this way. That means this thing can be written as integration of dm into r, or you can say r into dm divided by integration of dm. That gives the r sentence. Okay, this is that. So what is this r? R is the r coordinate of the dm, or r is the position vector of the dm. Okay. So by this method, integration method, I want to calculate this. So initially what I am doing, dm1 into r1, dm2 into r2. So this is nothing but the summation of all those dm. So summation of all those dm's means the integration of r dm. And the denominator summation of all those dm1, dm2, that is again another summation. So integration dm. So integration of r dm divided by dm, that is the RCM. So I can formulate this problem into three different parts. So what is that? For calculating x center of mass, I should use the formula that is integration of x dm divided by integration of dm. Okay. Similarly, y cm should be equal to integration of y dm divided by integration of dm. So like this, I want to get the three different components of this result, that is either xc or yc or zc. Okay. So be very careful regarding the dm. So dm is what? dm is the element. And what is x? X is the x coordinate center of mass of that particular. X is the center of mass of that dm element. Y is the center of mass of that dm element. Like this. Okay. So this is the basic idea to calculate the x center of mass, y center of mass, z center of mass. These are the three formulas that I am going to use to solve the problem. Okay. Now in this situation, you have to apply the concept of symmetry also. Means if the entire geometry is symmetrical, let us say about x-axis. Okay. Let us say I am saying there is a geometry of this type, geometry of this type. And if I say the geometry is symmetrical about this y-axis, symmetrical about the y-axis, that means whatever be the right side, same is the left side. So that means the center of mass should lie always on this y-axis. Okay, always on this y-axis. So if I say this is another type of geometry, let us say this geometry is symmetric about this x-axis. About x-axis it is symmetrical. So that means the center of mass should lie on this x-axis. Okay. That means if I found that one particular geometry is symmetric about one particular axis, then you don't have to calculate the center of mass value for that axis. You have to calculate only the center of mass value for the other axis. If the symmetry is about y-axis, calculate the center of mass for the x. Okay? X center of mass. Let us say this is the rod. Okay. So you are asked to calculate the center of mass of the uniform rod of mass m and l. So whenever the question is given for the uniform rod, that means you have to check that this is of same beam. Uniform means constant density. Density is constant. So that means it should be at the midpoint of that. It should be at the midpoint of the rod. But I should get the idea of integration over it. So if I say there is a rod of uniform rod and constant density, that means if I say lambda is the mass per unit length, so lambda should be equal to m by l. Okay, unit is kg per meter. So lambda is called the mass per unit length or the linear mass density. It is also known as the linear mass density. Okay, so first we calculate the linear mass density. Now from this point O, I move by a distance of x along the rod and take an element of dx. Okay, this is the element dx. Now this element has mass is, let us say, dm. Dm is the elemental mass. What is that mass? That should be lambda into dx. Why? Because lambda is the mass per unit length. And what is the length of the element? Dx. So dm should be equal to lambda into d. Now I should write that x coordinate of the rod xc should be equal to integration of x dm divided by integration of dm. That is our answer. That is the formula. Now what is x? X is the x coordinate of the center of mass of the element. So element is this. So this is the center mass of this element. This red dot. Now, so theoretically speaking, the red dot should be at a distance of x plus dx by 2 from this origin. What is x? X is the x coordinate of the center of mass of the element. So that number should be written as x plus dx by 2 into dm. integration, and in a remember it is again integration dm. Once I solve this numerator, once I solve this numerator, so I am getting this x dm number in the integration part, and another integration is dm into dx by 2, integration of dm. Now, since I know that by notation, I know that dm is very small number, dx is also very small number. So product of these two small number makes it further small. So you can simply eliminate. So that means this is eliminate that. Okay. So I am left with the integration of x dm divided by integration of dm, that same formula. Okay. So what is x? X is simply x. Now integration of dm is nothing but total mass. Integration of dm is total mass. So total mass in the question is given as capital M. So denominator is capital M. What is x? X is our x. Now what is dm? dm is lambda into dx. Integration. Limit is from 0 to L. Limit is from 0 to L. So lambda is constant. Only thing is x dx means x square by 2. So ultimately, if I simplify, lambda is constant, x square by 2 means L square by 2. Now what is lambda? Lambda is m by L. M by L into L square by 2m. So ultimately I am getting L by 2. Okay. So that is always true for the constants. If the mass is constant means uniform rod, then it should be always at the geometric center. What is the geometric center? That is equal to L by 2. But that is not true if the mass is irregular. Okay. But what I yes. Okay. In this equation, the mass is different. Variation is given as mu equals to L not x by L. That is what is mu? Mu is the linear mass. That is the same lambda that I have taken. Okay. L naught is one constant and x by L. So for this again I have to apply the constant integration. So if I move by a distance of x, same logic. If I move by a distance of x and take an element of dx, so this element of length dx. So for this, what is the mass? dm should be written as mu into dx. Nah. That means it is equals to L naught x by L into dx. L naught x by L into dx. So correspondingly, what you can write, x center of mass should be equal to integration of x dm. Integration of dm. So x is x. So L naught by L comes out x square dx in the numerator divided by L naught by L comes out x dx in the denominator. Okay. So L naught by L cancels out. Ultimately, limit is from 0 to L in the numerator, 0 to L in the denominator. The numerator is L cube by 3 and denominator is L square by 2. So ultimately I am getting 2L by 3. Okay. So 2L by 3 is the answer. That is not it at the midpoint. Okay. So answer will be different depending on the variation given. If the variation is different, then the answer may not be 12 by 3. So this is the variation. So entire answer depends on what is the nature of variation. Depending on that, the position of center of mass will be different. Okay. So there are some situations where we can apply the concept of symmetry. The center of mass of the symmetric bodies are always at the geometric center. So for a ring, this is the geometric center. For a disc, this is the geometric center. For a square plate, this is the geometric center. What is that center? That is nothing but the intersection of the diagonal. For cube, again the geometric center. Hollow cylinder, again geometric center. So for all the symmetrical body, center of mass is not in at the geometric center. But if I cut the ring, let us say I cut the ring into two halves. That means now I am getting a ring like this. Okay, this is the ring. So can I say this is symmetrical body? No, it is not a symmetrical one. It is symmetrical about this y-axis. Okay, so it is about the y-axis. It is symmetrical. So on right and left, so symmetrical about y-axis, it should be lying on this. So this should be a center. It is not at the geometric center or point. Okay. So for symmetrical body, it is always at the geometric center, but for non-symmetrical body, you have to calculate. Okay. So similar is the situation here. So first problem we say this is a symmetrical body. Symmetrical body. Why symmetrical? Because it is uniform rod. So that means the center of mass will be at the geometric center. Geometric center is what? half of the length of the rod. But in the second situation, it is not the symmetrical body. Mass is not evenly distributed. Right hand side mass is more, left hand side mass is less. So that means mass is not evenly distributed. So that means it is not a symmetrical one. So if it is not a symmetrical one, then the center of mass is not at the midpoint, which is somewhat different. Okay. So same logic applies over here also. There are two types of body, either may be symmetrical or may be asymmetric. Okay. So this is the complete set. This is the complete set. You have to remember that. So there are different geometry: semicircular ring, hollow hemisphere, hollow cone, solid hemisphere, semicircular disc. For those geometries, these are the values of the center. So we just calculate this. Yes. You can use those, but you have to know how to calculate, because these are basically the formula or the value, keeping in mind that every time we assume for those geometries density is constant, uniform mass. Uniform mass. Okay. For uniform mass, then only these formulas are valid or these numbers are valid. If the mass is not uniform, let us say I make a hollow hemisphere in such a way the plate material that I have used is denser on the lower part, whereas on the outer part. Then we it is not same or y. So that means we should get that idea how to derive this. How to derive this. Okay. So first your task is to remember these numbers. Next you go for the derivation. So once I go for the derivation, so then I understand how we can get these results, but that will give an idea that how to calculate the center of mass for the distributed mass. Okay. With that idea, now if the variation is given, then only you can calculate. That means initially we do this problem. And in this situation, the lambda number or the mass density is constant. Okay. Now, if the mass density is variable, then also you can apply this concept, same concept. I am applying same concept. Idea of taking the element is same. Integration is same. Ultimately, result is different. Why? Because the mu is different. Same logic goes over here. Initially, we entirely solve this problem, assuming that whatever the density that comes, lambda or something other notation we are using. But idea is that you assume that uniform. But the same problem can be translated to another situation where I apply the variation is given, that is the mass is variable quantity. Depending on that variation, you have to apply the same format to get the differences. Okay. So in the next class, we will go for the second part, that is the calculation of this problem. But first you practice this formula to remember. Okay.